And next is the time scaling. So time scaling, in the sense, we are going for scaling process in the time domain. What is our time domain parameter here? Small n is the time domain parameter. So we are going to, either we can do scale up operation or scale down operation. Scale up operation, in the sense, here this is the example for the scale up operation. So original signal is g of n. This is my original signal. If I am doing my scale up operation, then g of 2n. So here in general we can have g of lambda n is the equation for time scaling procedure. So the lambda value here is 2. So I am doing my upscaling procedure. If I am having my lambda is equal to, for example, 1 by 2, that is, then I can able to calculate my signal as g of n divided by 2. That is downscaling, right? So we can do our scaling process in the time domain parameter small n. So depending upon the value, amplitude value available in our original signal. Look at here. So here this is my position n, 0, 1, 2, 3, 4, right? So if I am calculating at 2n, then 0 will be 0 into 2 into 0, so 0. And if I substitute my value n is equal to 1, then 2 into 1, 2. So g of 2n, 2n value is equal, if I am substituting n is equal to 1, then g of 2 will be calculating. And for 2, n is equal to 2, g of 4. And n is equal to 3, g of 6. Likewise, we will have our data for the time scaling parameter. And this is for the time scaling in the continuous domain.